everyone. In this video, we will identify rational numbers and irrational numbers. Identify all of the rational numbers from the following. Before we get started, let's review what rational and irrational numbers look like. Rational numbers are any number that can be written as a fraction. An irrational number is a non-repeating infinite decimal. A rational number can be a repeating infinite decimal. This may be a single repeating number or a group of repeating numbers. If I have the number or the decimal 0.33 repeating forever, this is actually the fraction 1/3. The final type of decimal is a finite or ending decimal, one that will come to an end. Now that we have our definitions, let's evaluate our numbers. The square root of 36 evaluates to the number 6. Any whole number can be written as a fraction by putting it over a 1. 6 divided by 1 is 6, and by putting it over a 1, it makes it a fraction. So this makes it rational. So the square root of 36 is a rational number. Our next number has a line over the 8, 3, and 9. This means that the group of 8, 3, 9 repeats in the pattern 8, 3, 9 infinitely, which falls within our repeating infinite decimals. Therefore, this number is a rational number. Our next number terminates at 8. This does not have an ellipsis or a dot, dot, dot at the end, so this means that it is a finite decimal and falls within the rational numbers. The square root of 434 on my calculator is a decimal of 20.832, and while the 6 does seem to be repeating for a while, there is a 5 that breaks up the pattern, and then a 6 again. So this would indicate that it looks like it's repeating, but it's not. So this one is not a rational number. The next number has an ellipsis, indicating that this will continue, this number or decimal will continue on infinitely. And there's no repeating line, so this is also an irrational number. Both of these are irrational. The square root of 956 plugged into my calculator gives me a decimal of 30.9192496674, and again, this one is non-repeating, so it also falls within the irrationals. So the only rational numbers in our list are these ones that we've indicated here, because they all fall within the ability to be written as a fraction, an infinite but repeating decimal, or a finite decimal. And we're all done.